On the board is the chart of the problem we're trying to solve, having lots of different data types and lots of different operators, and that gives rise to m times n different ways to do things, and trying to keep a handle on all of that. And we've looked at two different organizing principles. The first one was take vertical slices through this table. And this the book calls conventional programming, again, because this is how you do it if you don't think very hard, because of that noun-verb distinction that everybody has in their brains. So we organize around the verbs, and we write a procedure area that has built into it all the area formulas for every possible shape. That's not so good, because if we want to add a new shape, we have to go edit a bazillion procedures, and we're bound to introduce bugs in things that used to work. So instead, we have this idea of data-directed programming. And up in the top half of the screen, you see data-directed programming as we're using it to solve this problem. And just to remind you, on the bottom half of the screen, we see a chunk of a completely different way of using data-directed programming in order to automate the writing of compilers for programming languages. So instead of having to write each compiler from scratch, we write one generalized compiler. It's an extreme example of generalizing patterns that I talked about back in week 2 when we introduced higher order functions. And it started with generalizing the pattern of finding areas of shapes by introducing an extra variable that says what the shape is. This is an extreme example of generalizing patterns where we just build one compiler that can compile any language by virtue of an auxiliary data file like this one in the bottom half of the screen that describes the syntax of whatever particular language we're trying to compile. And so these days, every specification for every programming language has an appendix that says, here's the BNF for this language, and it looks something like what you see on the screen there. I just should point out that we're kind of privileged in having procedures as a data type in our language, because we can put in the table a direct executable representation of what it is we want to do. In this other kind of data-directed programming, exemplified by what's on the bottom half of the screen, you have to write some more software to take this notation, which is just strings of characters, and turn it into something executable that actually compiles your program. And for us, the only function like that we need is this little 5-line operate procedure where the cursor is blinking that looks up the thing in the table, and if it finds something, it just invokes whatever it finds directly on the operand. Okay, so that's kind of nice, and it makes data-directed programming particularly easy for us, so easy that it probably doesn't feel like much of a big idea. And that was the other reason I wanted to show you the BNF thing, to impress upon you not only that it's a more general idea than just solving this particular problem, but that it really is a big, complicated, it was a big step forward in thinking about computing when they invented it.